Hi everyone, this is Madhuri. Welcome to my video recording. The topic I chose today to explain is master theorem for linear decreasing functions. So I'm going to take a basic program, a small function, to understand how the master theorem works. So there is this method void test is equal to int n, which takes an input n. So we are going to consider Tn as the time it takes for this function to run. So it has a loop if n is greater than 0. Then we are going to print the value of n, and then we are going to call test recursively with n minus 1. So every time we are going to reduce n by 1 and then call the same function recursively. So as we all know, print statement is going to take a constant time. So let us consider 1. And test n minus 1 is going to run for n minus 1 times if n is the input. So by this we know that t of n is equal to t of n minus 1 plus 1. So that is going to be our recursive function. So in this function you can always convert n minus 1 in terms of n minus 2. So if t of n is equal to t of n minus 1 plus 1, then t of n minus 1 is equal to t of n minus 2 plus 1. And then if you resubstitute, it's going to be t of n is equal to, you can get it in the form of k. So if you keep doing it for k steps, it's going to be t of n is equal to t of n minus k plus k. So if you keep reducing and keep subtracting 1 from n in k number of times, so we can assume that n of k is equal to 0. Like if you keep subtracting 1 at some point of time, n minus k is going to be 0. So we are going to consider that that particular step is k. So therefore n is equal to k. So in this particular equation, we are going to substitute n is equal to k. So wherever there is k, we are going to substitute n. So t of n is equal to t of n minus n plus n. So this is going to be 0. T of 0 plus n. So when the value of n is 0 in this particular method, it's just going to print, and then there is not going to be any recursive call, like it's going to be minus 1 and then it comes back and n is not greater than 0. So that's it. So it's just going to be the constant time, which is 1. So it's 1. So t of 0 is 1 plus n, which is big O of n. So t of n is equal to t of n minus 1 plus 1 is big O of n. And t of n is equal to t of n minus 1 plus n is big O of n squared. And if it is log n, it's going to be big O of n log n. These are the equations that are explained by our professor during class. So I'm just going to explain the basic one, but all of the other explanations are available in our class recordings. So let's go to our lecture. And so every function is going to be in this form. So it's t of n is equal to a times t of n minus b plus f of n. So whenever we have an equation, we convert it to this form and find the values of a and b. So if the values of a and b are greater than 0, and if f of n is big O of n power k, where k is greater than 0. So they are going to be 3 cases based on the value of a. So if a is 1, then the time is going to be big O of f of n into n. If a is greater than 1, it's going to be f of n into a power n by b. And if a is less than 1, then a power n by b is going to be a really small value, so we are just going to ignore it. So let's see a few simple examples. So in this particular equation where t of n is equal to t of n minus 1 plus n log n, we can see that a is 1, b is 1, and f of n is n log n. So as a is equal to 1, it's going to be case 1, where a is equal to 1. So the time is going to be big O of f of n into n. So f of n is n log n into n. So it's going to be n squared log n. And let's consider another example where t of n is equal to 2 times t of n minus 1 plus n cube. So from this equation, a is 2 and b is 1 and f of n is n cube. So as a is greater than 1, time is going to be big O of f of n into a power n by b. So substituting the values of a and b, it's going to be big O of n cubed 2 power n. And let's take a third example where a is less than 1. So in this a is 1 by 2, b is 1, and f of n is n. So if a is less than 1, the case is going to be third, and it's just going to be big O of f of n. So big O of f of n is big O of n, since f of n is n in this. So that is it. Thank you. I would also like to thank our professor for giving us this opportunity wherein we can teach to our peers. I always believe that teaching is the best way of learning. So when you teach, you understand things better, and that's how I understand things better. So thank you.